Hi, my name is Nai Wu, and today we'll be looking at lab number 2, lines of charge for Physics 2212. So for the introduction, the purpose of this lab is to further develop our knowledge of how charged objects interact with the environment. And in this lab, we use a much more accurate model to calculate the charge. So the difference between lab 1 and lab 2 is that for lab we'll still be using the initial calculations of charge in lab 1, but instead of treating the tape as a point charge, we'll be treating the tape as a line of charge. And as a result, the positively charged tape, which is modeled in equilibrium and as line charges, will have a charge around 2.96 times 10 to the negative 8 coulomb, a larger value than the previous 1.74 times 10 to the negative 9 coulomb. So for the fundamental principles and assumptions, it's the same as in lab 1. We end up using Coulomb's law, electric fields, force on charged objects, force of gravity, and Newton's second law. And for the assumptions, we assume that A, the charge is uniformly distributed across the tape, B, forces due to air resistance are negligible, and C, each tape has around the same amount of charge. The procedure is also the same as in lab 1. We basically take two charged tapes and have one underneath the other one. And by doing so, they repel, and the second tape above will rise up a bit. And using that separation distance, we can find the charge on the upper tape, tape B. So some calculations from lab 1. First, we calculated the gravitational force. And afterwards, using the gravitational force and the separation distance we measured, we can find the charge on tape B. We also end up finding the corresponding number of electrons on tape B and the fraction of atoms that gave up their electron on tape B. So the difference between lab 1 and lab 2, as you can see, if we input our numbers from lab 1 into lab 2, the model does not it's not in equilibrium. As you can tell, the magnitude of the gravitational force is much greater than the magnitude of the electric force. So in the next few slides of coding, we'll take a look at how we can fix that. So the first few lines of the code includes most of the physical constants and the input of certain data. So as you can see, we have our constant K and our gravitational force 9.81 times 9.81 meters per second squared. We also put in our mass of the tape, the separation distance, the length of tape, and right here specifically, this line right here, 0 GQ. This one is our original charge that we found in lab 1. However, through some calculations, we were able to find Q of 2.96 times 10 to the negative 8. This charge right here does make our model into equilibrium. This second section of code is used to find the electric field, and this other section of code is used to actually make the line charge, the function for a line charge. And then these two lines of code here is to actually physically place the tapes onto the model and like where to put the tapes. And then last but not least, right here we're trying to find the total electric field due to the force of the top tape onto the bottom tape. And by doing so, we can actually find our number. Last but not least, we need to visually create the force vector. So as you can see right here for line 139, 140, we create an arrow for the electric force. And then from 142 to 143, we create the arrow for the gravitational force. And at the end, we get this result. As you can see, both the electric force and the gravitational force are at equilibrium once again. So for questions, what if you had modeled each of your tapes as a single point charge, like in the previous lab? So as you can see, we tried this before, and basically we get a 1600% increase. So there is a huge difference. And second one is why do these estimates differ? Which value is more likely to be closer to the real value and why? So lab 1 assumes that all charges on the tape were concentrated at one point. But as we can tell from this lab, that isn't true. In reality, the charges are distributed among the tape, which makes lab 2's model much more accurate in terms of the real world.